Okay, so we are going to do just a tutorial, and then tomorrow I'll go to revision with you. Okay, so your test, MSc test on the 8th of December, 1:30 p.m. All right, to treat that 1.5 hour. Okay, let's start the tutorial. So today I will try to go through 18 and 22 with you, and then you do the rest. All right. So and then this will finish chapter 2. So let's start reading the question first. A ship leave a position 35 degree 40 minutes north, 141 degree east, and follow a quick circle track. The initial course is 60 degree, and find the latitude and longitude of the vertex now. Because remember, this time we see vertex again. So revision of what is the vertex here. Okay, so let's try to see how it look like. Okay, so I'm going to draw the Earth first. So let's draw the Earth and see a picture first. So let's say this is the Earth, the equator. Okay, so let's call this point A. So this is North Pole here. So this point is A, making a latitude of 35 degree, 40 minutes. So somewhere the center here is the center of the Earth. So let's draw the point A is here now. So this angle, let's say A is here now, 35 degree from the equator, 35 degree, 40 minutes, this angle. Okay, so the ship actually leave this position and follow a great circle track. Initial course 60 degree, which means that, okay, if this is going towards the North Pole, so 60 degrees is somewhere here. So you get a 60 degrees somewhere here. And from the North Pole, from the North, we travel east, right? So you can see that this is the direction of going east. Uh, 60 degree 30 minutes. So you move along a great circle. All right. So find the latitude or longitude of vertex. So vertex is the nearest point to the North Pole. So somewhere here's the North vertex here. So I just draw the vertex here. Okay, vertex here. Vertex, all right. So P is the North Pole. So just to make it clearer, P is North Pole here. So the question we want to ask is, what is the longitude and latitude of the vertex? The longitude and vertex and the latitude of vertex. So we draw a picture already. Let's say A is 141 degree east. So this is actually 141 degree. east, right? Okay, so let's see how do we go about this. So because this is right angle triangle, eventually we have to use a Napier's wheel, right? So because the right angle triangle of this here, you need to use Napier's wheel. But before that, let's do some calculation first. One of them is to find PA. So this is called co-latitude of A. What is that equal to? Okay, you can see that this is equal to 90 degree minus 35 degree 40 minutes, which is PA here. This is PA here. PA is the co-latitude of A. So that is actually equal to 54 degree 20 minutes. Okay, so and V is a text we don't know, right? So you're going to find out. So so far we know the angle A is actually 60 degree 30 minutes. So let's draw the Napier's wheel here first. So I'm going to the next page to draw a Napier's wheel. And you know that PA is 54 degree 20 minutes now. So right here 54 degree 20 minutes is a PA. And then we're going to redraw this again. So let me go to the next page now. Edit, select the page there, edit, copy page there. Okay, go to the next page here. So I'm going to redraw the triangle again, all right? So I think I'm going to redraw triangle. So let me erase this, all these things now. So I don't need all this. So let me redraw it here. And let me shift this away. Okay, so the V is here. V is this one, the vertex 90 degree. So let's it is 141. So let's draw the Napier's wheel. Okay, Napier's wheel you have to learn because the MIT will test you. So Napier's wheel will look like this, and then upper half divide two parts, lower part divide three parts. Okay, V is 90 degree. So go from P to V. Okay, go from P to V first. So it's PV, which I don't know yet. So write PV here. And then VA, which I also don't know yet. So I write now VA. And then angle A. Okay, angle A we know is 60 degree 30 minutes. And then AP, right? AP we know is 54 degree 20 minutes, and then angle P, right? Then you have COM there. So this is Nepier's view. Okay, so from there, okay, I know PV, I know A here, I know AP here, so I can find PV here. All right, so use a Nepier's rule. So Nepier's rule say that the Nepier's rule will be given to you in the MST, so you don't need to worry. You just have to memorize the formula here. Nepier's rule say that sine of the middle part, okay, middle, because now I have opposite now, so I put out our cosine, right? Put out opposite. So the opposite is A and AP, both are inside lower view. So you have to use COM now. So this is actually sine of PV is called cosine of COM A and cosine of COM PA or AP, same. Now cosine of COM A is the same as sine of A. Cosine of COM PA is same as sine of PA or AP here. So put in the value of A is sine 60 degree 30 minutes, and sine PA is 54 degree 20 minutes. So now you press the calculator. You get PV is 45 degree, right? Okay. Again, PV 45 degree, of course that 0.7070. So PV equal to sine inverse of 0.70, which is around 45 degree. So the PV is around 45 degree. What is the latitude now? So latitude, if you remember latitude, if we go back to the earlier diagram, okay, earlier diagram here, the latitude is measured from, okay, this V here. So this one is PV we found earlier from Nepier's rule. Nepier's rule is 45 degree. So this one is 45 degree here. Therefore, what is the latitude now? Latitude of V now, you can set that, okay, latitude of V, this one must be, so from the measure from the equator, so this one is also 90 minus 45 is also 45 degree. So this part here is 90 minus 45 here. So from here to here is 90 minus 45. So it's 45 degree. So this angle is 45 degree. And there's a latitude. of the V, 45 degree north. Okay, so I know the latitude of V is 45 degree north. So I'm climbing here. So I write one more sentence. So latitude of V is 45 degree north. Okay, PV is 45. So this is 45 now. Okay, I know the PV now. Next thing, I want to find the longitude. All right. So again, when you do the sine inverse, there are two possible answers, right? Sine inverse are two possible answers. Cos diagonal or PV equal to 180 minus 45 with 135. But you reject this one. Because the angle cannot be so big, like 90 degree has 54 20 minutes, right? 90 degree at 54 20 minutes. So this one cannot be more than 54 20 minutes. So it's 45, it's okay, right? So this is the reason why we reject the bigger angle. Okay, now I want to calculate the longitude now. So let me WhatsApp this to you first, okay? Maybe after a while I forgot to WhatsApp this to you. So I go back to earlier page first and WhatsApp this to you first. Okay, so I WhatsApp this to you. I think it's easier to get reference in this way. Okay, then the next page here. Okay, so all right. So the next page now, I copy this thing and continue. Edit, copy the page here. Copy page first. Select page. Copy page first. And go to the next one. So now I want to find the angle P, okay? How far away the longitude. So now I want to use angle P now. So I know this 45 degree. I know AP here. So now I want to find angle P. So I'm going to use the color code again. So this one is AP, I know. Okay, AP is yellow here. And then PV, I know it's yellow here. And then I'm going to use it as P as the one I want to find. So I'm going to use a different Napier's rule now. So let me erase all this here. Okay, so now I want to use the sine meter part equal to product of tangent, also forgot to mention cosine, right? So this now is tangent now. Okay, sorry about that. I should mention that this now is tangent. It isn't. Whereas earlier one, product of cosine opposite here, right? So this cosine opposite here. So I should mention this one because sometimes I forget. So maybe I will WhatsApp this to you again. Okay, so I continue. Tangent of adjacent now. So middle part is P now. And happen that this is actually in the lower end, lower part of the wheel. So this is actually sine com P. Okay, angle P. Now the tangent of PV on top and tangent of com AP, right? Because you need com there. So sine of com P is same as cosine of P now. Sine of com P is same as cosine of P now, and tangent PV is let's have one more step here. Tangent PV and tangent com AP is 1 over tangent AP. So this will give you tangent of PV is 45 degree and 1 over tangent of AP. AP is 54 degree, 20 minutes. So from here I find out what is com P now. Press the calculator. It's 0.7176. Okay, 0.7176. So P is equal to cosine inverse now. 0.7176. And this will give you 44 degree, 8 minutes. And this angle P. So from here I can find the longitude of P of V now. So because that means that this angle is 44 degree, 8 minutes. So because the ship is actually going to the east, right? Going to the east, right? The ship is going to the east, right? The ship is going to the east. You can see the angle is 60 degree going to the east, and the angle P is 44 degree 8 minutes. So the longitude of V now is starting from A, which is 141 degree east, and going to the east, so you add another 44 degree. Okay, 44 degree, 8 minutes. So you get 185 degree east. Okay, 185 degree 8 minutes east here. So I can move that. Add together, you get 185 degree east. But we know we don't have 185 degree east, right? So you have to subtract now. So this is actually what is you actually go into the west side of the Earth now. So this actually convert them 360 minus 185 degree 8 minutes. So we actually go to the west side of the Earth now. All right. So this is actually 174 degree 52 minute west, and that is the longitude of the vertex V now, because the ship actually moved to the east. Okay, and you find out the angle, the latitude, the longitude is now 185. Of course, it cannot be 185, right? So actually, how much actually go to the west already, right? So what is actually the, okay, but it's actually from the west is 1474, 52 minute here. So this is how you get the longitude here. Okay, so WhatsApp this to you. So WhatsApp this to you, yeah. So that finished the calculation. For question 18, all right? So yeah, move on to next question. I'll do question 22, which is more very interesting. Okay, so question 19, 20, and 21, you do yourself, all right? And move on to do 22. Very interesting, yeah. So question 19, 20, 21, and you do yourself. I'm gonna move to 22 now. So let me see. Okay, 22. Where's the question? Okay, I'm gonna do the question here. Okay, so copy the question here. Okay, and copy the question here and start fresh. Okay, so this question is interesting because I take a while to figure out the answer, right? Because the answer is not obvious. Okay, let's try to draw the picture of the Earth first. I think it's easier to understand. So let's draw the Earth picture first. So I have a planet Earth first, and so this equator, and this North Pole. Okay, a ship sail along the Great Circle track from Dutch Harbor, which is from the left side of the Earth sphere. So is 166.35. Okay, so let's say this is I'm going to turn the circle around, okay, so that you can see better, right? So I'm going to use this as 166 degree 35 degree west. So I turn it, look it from the Earth from the other on that side, right? So I'm going to turn it this way, and the Dutch Harbor is 53 degree. So from the center of the Earth, so the Dutch Harbor is somewhere here. Okay, let's call this the point A here, and this 53 degree, 53 minute, right? So this is the Dutch Harbor A, right? And then There is another point, Melbourne, 37 degree, 50 degrees south, and 14459 east. Okay, so I'm going to, as I say that, I can turn the Earth from the other side there, so it's easier to see. Because how I come to this, because I try to draw a diagram, and then I find that the diagram doesn't work, and then actually understand it why it doesn't work now. So I must draw it carefully. So the North Pole here. So next, Melbourne is on the south now. So south of 37 degree. So this is 37 degree, 50 minutes here. Go to south here. So this is actually the point A, Touch Harbor. This is Melbourne here. Let's say code B here. Okay, B is here. So let me use a red color to highlight here. So this is actually Touch Harbor. This is Melbourne. So the ship actually go around from A to Melbourne. Okay, A to B now. On a great circle. Okay, so I have this PA fixed here. So PA, let's see, I can see for you. Okay, draw for you. So PA is fixed here. PB, all right, so North Pole to B here. So let me try color here. PB is this one. So you go from A to B, right? So along the great circle. So let's draw the great circle here. So from A to B. So let me draw the great circle here. The path. Okay, this one to B. Great circle is a circle, pass the center of the Earth. Okay, so the distance it travel, or the path it travel, is actually this blue one, the blue color here, from A to B. This one. Okay, so this is how the graph look like. So let me use a different color so that you can see that this is actually moving along here. The ship go from here to here. Okay, so let me highlight here so that you know that this is the ship movement. Okay, the ship movement here is actually the one with the red color one. Okay, so you can see that the ship actually move to the west. All right, if you continue moving, that this is the west here, in the west direction. Okay, so the ship actually move westward until they get the east. So this one is a Melbourne. Okay, so this is Melbourne here is actually 14459 east, right? It actually moves to the west until they get east here to get the destination, and the path you can see that. So how do you find the distance PA and PB first? So correlative PA first. PA is easy. Calculate from North Pole is 90 degree minus 53 degree, 53 minutes. So PA, okay, you calculate is 36 degree, 7 minutes. Now PB is different calculation now. From North Pole to Melbourne is more than 90 degree, right? So how much is that? 90 degree from North Pole to South Pole, the North Pole to equator is 90 degree. Then you plus another 37 degree, 50 minutes. For the Melbourne, this time you get 127 degree, 50 minutes. Okay, so this is the first setup before you try to. Okay, so this time there is no 90 degree now, so you don't need the Napier rule now. Okay, don't need the Napier rule. So let me WhatsApp this to you. All right, so I know quite a few things already. And how do you find anchor P? Later on, let me calculate for you, right? So let me copy this thing to the next page here. Don't need this. Okay, so let me copy this one and also and this one. I'll do that. Don't need so many. Okay, copy paste. So I'll go to the next page and withdraw again. So now, how do you find the angle P? All right. So let me try to find angle P now. So I know PA is 36 degrees 7 minutes and PB is 127 degree 50 minutes now. So let me try to figure out the angle P. So the angle P, so actually the point move from A to B. So let me draw a picture for you. So this one, this A here, this B here. Okay, the point move from A to B. So this is actually the 0 degree or 180 line, right? So for the point move from A to B, how much actually move here? This is 166 degree 35 minute west. So how much move until 180 is actually, you can calculate here, until 180 is 180 minus 35, right? So 180 minus 35, you get take this 180 minus 166 degree 35 minutes here. So this part, the angle is 13 degree 25 minutes. Then continue to move, okay, to B. B is 144 59 is So how much the angle this time now is 180 minus 144, 59 degree. So this is actually calculate is 35 degree 09 minutes here. So total angle P, right? So total, add them up. So the total angle P now, so you take this one and this one. So P, the angle, is equal to, add them up, this one is actually 13 degree 25 plus 35 degree and then 1 minute. So you get 48 degree and then 26 minutes. This is how you find angle P. Okay, so this angle P, when you draw it, okay, so this angle P here, 48 degree, 26 minutes here, angle P. So, and I WhatsApp this to you. I think I will shift it around so that you can see it properly. So you actually move the westward there, move to the west here. And then you say move, as you move to the west, you see calculate the angle, how to get from A to B. So let me WhatsApp this to you. Okay, so now I'm ready to do calculation now. Okay, so I copy this thing now. I think copy this thing. We'll next page now. I'm gonna redraw a triangle now. Okay, so okay, you can see a better picture. I have example P. I have the A. I have a B. Okay, so I better draw it this way. And so this one we know PA is 37 degrees 7 minutes here. So PA 37 degree 7 minutes here. You can check here. Okay, 37 degrees 7 minutes, and PB is 127. Okay, 127 and 50 minutes here. PB, and you move from A to B along quick circle. So this is a quick circle here. Move here from A to B. And this angle we find out is 48 degree 26 minutes here. So what we want is find the great circle distance AB. So this is the distance we want to find. Okay, great circle distance. So how do you find which circle distance? We know exactly cosine, law of cosine here. So this is where you apply law of cosine. So you can say like, okay, cosine, this is length P now, or AB here. So this is length P here, opposite angle P, right? So P here, this is actually angle side A here. This is actually opposite B, right? So you can use this. So cosine of small p equal to cosine of A cosine of B plus sine of A sine of B cosine the angle P, right? Law of cosine. So this is actually cosine of A is 127. So 127 degree 50 minutes. B is 37 degree 07 minutes plus sine of 127 degree 50 minutes sine of 37 degree 7 minutes. Okay, so then cosine of 46 degree 48 degree 26 minutes. So you find cosine P first. I think I don't have answer, but you can find cosine P is what now? Let's calculator. So P in this case, check calculator is 100.755 degree. Okay, so how much is that? So you multiply by 60, like you want to find nautical miles. So you multiply by 60 in terms of nautical miles is 100.755 times 60 nautical miles, you get 6045. So this is a distance between A and B. Okay, this is the distance between A and B. So that will be finished first part now. Okay, create the circle distance between 2 points A and B. So let me WhatsApp this to you. Okay, so next thing I want to find is the initial cost. Let me copy over page here. Okay, next thing I want to find initial cost. Okay, so I know the length of PB now, AP now, so I just write down first. Is 100 degree, maybe I need them. Okay, so 100 degree, 1.755. Okay, so let's find initial cost. What is the initial cost? So let me erase this thing. Okay, initial cost, of course, this is going to the North Pole now. Okay, so we know that this is actually toward the east. Remember how to find the bearing, right? Bearing is this is the North Pole. This is point A, and then this is the and the bearing is actually from here. Okay, pointing toward east, right? The bearing pointing toward east for reference on that. So you will find that okay. So this is going toward westwards. So you know the A to B is west. So this direction is east now, right? West. So how to find the bearing here? Okay, the bearing is direction of the ship, right? Initial cost. So I have to find initial cost. Let me erase this one. Initial cost. Okay, I write the initial one. So direction of cost, right? Initial cost in this case, let's me draw a picture here. It's actually for measure from north direction to east, and then you find that this is the initial cost from all the way direction the ship movement, right? So the alpha here, initial cost. Okay, alpha initial cost. All right. So for the north, measure from to the east, and then you see where's direction of the ship, alpha here. Of course, in this case, you need to know what is anchor A. Okay, what's anchor A now, right? So need to find anchor A. So need to find anchor A now. So you can use a sine law to find anchor A. Okay, let's do a sine law here. You'll use sine law here. Okay, use sine law for angle A. So spherical triangle, no? So you must use spherical triangle. So sine A over sine of sine A equal to, let's say, sine of P, angle P over sine of side P. So sine A here is equal to sine of angle P. The sine angle P here, so better use big letter here, times sine of angle A, sine of side A over sine of side B, side P here, small p. So this is actually sine of 48 degree 26 minutes for P, angle P, and sine of side A is actually 127 degree 50 minutes, and side P is actually, let's use a exact value here, sine of 100.755 degree. So you get sine A now is equal to 0.6015. So sine A is 0.6015. What is A now? So A is equal to sine inverse 0.6015 and give you 37 degree. Now you have to reject this one. Or another one is this one. Or A equal to 180 minus 37 degree is equal to 143 degree. Okay, why we have to reject this one? Reject. Because A cannot be so small, right? Because the side opposite A is 127. It's a longer side. So that means that A cannot be so small. So the A must be 143 degree. So A is 143 degree now. So this is 143. Okay, this part is 143 here. So what is the bearing of initial cost now? So initial cost is actually, let's look at the calculation now, is 360 minus 143, right? Because one whole round is 360. So 360 minus 143. Okay, and then you find that this is actually 217 degree. Okay, bearing is 217 degree here. So it's 360 minus 143. Get 217 degree true bearing. So the alpha here is equal to, after subtract here, is 217 degree true bearing. Okay, this alpha initial cost. Okay, 217 degree true bearing. This is for finding the initial cost. So let me WhatsApp this to you. So there is the answer. How you see the answer here? I have this 143 here. Okay, 143 here. So okay, minus 143. Okay, 217 degree true bearing. So let me WhatsApp to you this better. You can see the picture. Okay, next one, I want to find the final cost. Okay, cost on arrival, final cost. So let me copy this again. So I want to find the final cost now. So cost on arrival means final cost. We call it beta here. So let's say final cost. Okay, so let me erase the information. Let me tell you what is the final cost here. How do you do that? How do you find final cost? Remember, this is the direction to the east. Okay, this is to the North Pole. So the final cost in this case is this angle now. beta final cos, right? The direction it moves. So beta is the final cos. So that means that you need to figure out what is angle B first. Okay, angle B first. So I'm going to use a sine law again. But I can change the angle B now, right? So same. So let's use sine law, this angle B now. Okay, so everything that change, this angle B now. And this angle B, side B. So the B is 37 degree, 07 minute, right? So I'll change it here now. So this one, 37 degree. Okay, so I now find what is angle B now. Sine B. Okay, what was my sine B equal to 0.4596. So you can find B now. B is 0.4596, agree. So this equal B equal to 0.4596. And you find out what is this angle now. This angle is 27 degree. Third 22 minutes. So there's another angle. Just take this one, minus 22 degree, 37 degree. -22 here, and then you have a big angle. Okay, so big angle here. Okay, this is actually 153 degree. 48, right? 38 minutes. But you can see that the side B is a very small side. Okay, side B is a very small side. So you have to reject this one. Reject. So side B is 22 degree, 24 minutes, right? So this is actually 27 degree, 22 minutes here. This side B. So now I can find the final cos now. The final cos you can see from the straight line. All you need is actually plus 180 degree, right? So final cos is actually this 27, 22, then plus another straight line. So this part you get a straight line 180, right? So actually is 27 degree, 22 minutes plus 180, and then you'll find that this is actually 207 now. about 207 degree true bearing. Okay, so this is actually 207 degree true bearing. Okay, from the here to here, right? You want to see the bearing, this 207, whereas this one 217. Okay, so you find the final cost, which is beta here. So the final cost is beta. Beta here. Okay, so this is the last example exercise I'm going to show you. It's a quite interesting exercise. Okay, so for that I will stop here. I think this is enough already. Tomorrow we will do revision, okay, for MST. Right? Tomorrow we are doing revision for MST. So come for class, right? So for those people who are absent today, okay, tell them must come to class, right? Okay, so I think the people who are absent today. Okay, so I have quite a few. Muhammad Danish not here, and then okay, I will remind them to come to class tomorrow. Okay, that will be all for today. Thank you very much. I'll stop recording now.